welcome everyone to our webinar today, hosted by MergeBase. Today we have Jim Manico, myself, Julius Musseau, Farshad Abasi. Here we're talking about the very serious application security concern, how to avoid catastrophic cryptographic failures in your applications. Okay, so I just ask everyone.
Hi, Julius. Hi, Farshad.
Introduce themselves here.
How's everybody doing?
Yeah, doing good. I've got a little 3-year-old in the background. I'm in a power outage right now, so I'm just on the batteries of my phone and my laptop. So if I disappear, guys, you're in good hands. So Jim and Farshad will keep this going.
Julius, you're a trooper that even with the power outage, Julius has got a power outage. He's got kids running around everywhere. It's like bedlam and chaos. He's got a candle so he can see, but he's got battery on his laptop, battery on his phone for internet, and he's still here with us.
He's still here with us.
You're a trooper. You're a trooper, Julius.
Thank you. Very kind of you guys. So who are we? Farshad, if you want to introduce yourself.
Hi, everybody. I'm the founder and chief security officer at Forward Security, OWASP Vancouver volunteer. I've been doing software for about 25 years, security for about 13 or 14 years of that. So lots of fun. Love to chat about these things.
And Jim.
My name is Jim Manico. I'm one of the advisors for MergeBase and several other companies, and I'm the principal at Manicode Security. We train software developers how to write secure code, damn it, and we have a lot of fun doing it. Julius, Farshad, good to see both of you today.
Yeah, and I'm Julius, CTO co-founder at MergeBase, which is an application security company focused on known vulnerabilities in the supply chain. And there's Joseph right behind me there. Hi, Joseph. Can you say hi, Joseph?
Right.
Yeah, he doesn't want to say anything.
Hi, Joseph.
Okay, moving on.
Joseph.
So yeah, for this talk, cryptography ahead, we're going to get Jim and Farshad's take. I made the slide deck, so put the slides in front of them and hopefully they agree with what I put, but maybe not. Maybe I'm wrong about some stuff here. Anyway, I love this quote by Pinboard. In the real world, Joseph, it does not burn down for you, especially is that actually if you do forget to tighten one of the screws, yeah, your house will burn down. It's a very real possibility. This talk, quick series of best practices for application security and things to avoid, quick things like, SHA-2 now is acceptable, MD5, certain death. On that note, let's proceed. The super short version of the talk is just this slide I saw on Jim's Twitter. Colin Percival had put together a web page on his blog.
Hey, Julius, do you know who Colin Percival is, by the way? He's a famous, and for that matter, Thomas Tychek, these are two really famous people in the world of applied cryptography. Colin Percival is the author of one of the few algorithms that's good for password storage, scrypt. So he wrote several famous papers and created that algorithm. And at a time when we didn't have a lot of great choices, came up with a really good algorithm for password storage for authentication systems. Thomas Tychek, he's one of the top brains in applied cryptography on the planet right now. And I think, and to see comments from these two people, these are not just some random Twitter people. These are like really substantial experts in the world of applied cryptography. That's why Colin's link there got really interesting to me as well. All right, Julius, you're up. I'm sorry.
I think he's turned into a robot.
I think we're losing him.
Yeah.
Maybe we shouldn't have had Julius run the slides.
You know what? I'm gonna run this. I'm gonna run the slides. I've got the deck here.
Let's keep going. Run those.
No, thanks for that. Yeah, I actually was not familiar.
Percival's super famous. He's the scrypt person. I like what Thomas and Thomas.
Can you guys hear me?
I like Thomas's advice. He's like, use a good library that supports AES and Galois counter mode and go. And I'm like, yeah. Google Tink, libsodium are examples of libraries that are good. I like the start already. Let's do this.
All right, there we go. So full disk encryption. Jim, take it away.
Yeah, you should.
Farshad, we're not quite on the right slide here. One second, I'm just gonna move the kid. Yeah, I wasn't that familiar with Colin Percival's work, although it's interesting to see on Twitter. It says he lives in Maple Ridge, which is just across the river from me.
Oh.
Just have to swim. Yeah, we just have, it just seems like we just have that first page of the PDF there, Farshad.
This is the slide deck.
Just a passenger on this spaceship.
Do you want me to advance for you, or?
Yeah, and here I'm going to try and move the kid to the bedroom.
Just for fun, I'm chatting the original paper by Colin, right? This, if you like reading like deep crypto, this is a real famous paper on stronger key derivation via sequential memory hard functions, right? He's talking about S-code. And even though it's a key derivation function,
that's
just like PBKDF2 in the federal government, if you're trying to be FIPS compliant, you're probably going to use PBKDF2, password-based key derivation function 2, a key derivation function to do password storage. There's a history for that. And scrypt, here's scrypt improving upon that circa 2009. So that when I see Colin Percival pop up, I'm like, he's no slouch. But we're slouches because we can't advance our slides. Let's advance some slides here. What are we doing?
Right. Well, I mean, we can talk about full disk encryption. There's a whole bunch of topics we can dive into.
Let's go.
Let's do it. Okay.
I'm happy to talk about anything.
Yeah,
related.
This one is like, I mean, I always do this. Like one thing I'd like to point out is that you can do encryption at different levels, right? Oftentimes, but particularly when you're talking to clients that are in the cloud, they get this misconception that, yeah, like they've encrypted it at whatever level. It's like, well, yeah, but is it at the disk? Is it at the volume? Or is it at the, like the block level? Is it a volume level? Are you encrypting at your like database level or at the application level? When do you need to encrypt at what level? Oftentimes not enough consideration is given to that, and they may not be doing the right encryption at the right level to prevent the threat scenarios that might apply to them. And
Absolutely.
So, like full disk encryption, I think at this point is a given, right? Like, I mean, if you're not doing it, then we got a problem. And then of course, this is, I believe by default, AWS, Azure, and GCP do that at the disk layer, if I'm not mistaken. And then, physical servers in your data center, of course, you should do that on your databases. Now, back to what I was saying earlier, when do you need to do it encrypted at the database level? Well, if you're concerned that a system administrator who can log into that operating system could go and fetch that file, because at the end of the day, whatever database you're running, it's saving all the data into a file in a file system. So if that's a threat that you're concerned about, that a malicious system operator can go in there and grab that file, then you should absolutely encrypt it. And then if you also have another threat scenario would be that you have a malicious database administrator. Well, encrypting at the database level is not going to prevent that attack. If you're concerned about a DBA going in there, well, what you got to do is encrypt it at the application layer. So really where you encrypt depends on what is your threat of concern or attacker of concern, I'd say.
And usually we want to encrypt at multiple layers. Like there's usually some kind of transport encryption, and there's some kind of encryption at rest, encryption when you're storing data. Those are the two main categories that we care about typically. Exactly.
All right, let's take a look at the next slide here. TLS considerations. Yeah, this is my favorite. Jim, you want to start, because we have lots to talk about here, I think.
Sure. Like, luckily today, when you're setting up your server for TLS, right? And by the way, you're not setting up your server for SSL. That's a dead protocol. You're setting up your server
That's right.
only for TLS.
That's right. Thank you.
And what I like to do is I use a combination of the Mozilla TLS hardening guide, and I use that in concert with SSLlabs.com or other scripts I see from the open source community to evaluate how well my server is configured. So again, I go take a look at, again, it's the Mozilla TLS configuration generator. And let me go get a link for that, right? It's easy to find. So okay, Mozilla TLS config generator. It's a well-supported project that's been around the Mozilla community for some time. If you want to put this up on screen, go for it, but there it is. I click on that. I specify what my server is, what kind of browsers I want to support, what library config I have, and similar, and they'll generate the initial config file for you. And
That's
so
excellent.
I'm just gonna try and go to that right now.
Yeah, and then I go to
Mozilla
SSLabs.com and
TLS
I check my server out, right? I go to SSLabs.com, I go tweak that config, SSLabs.com, and I go and I tweak that, I check that config with the test your server, and I submit a little test here, and I'm running a test right now against my server, and you can watch that test run but with that link is with there. So, and again, there's a lot of other ways to set up your TLS, and there's different levels of configuration you need based on your user base. When you have a bigger user base, there's a lot more subtlety in setting this up. But for a typical server, right, this is a pretty easy on-road into getting yourself really decent configuration out of the box in just a few minutes, and you fine-tune as necessary.
On the TLS, I want to add something too from a developer's perspective, is that I've seen, in fact, this week alone, when I was looking at a client's app, is I see that developers often disable that when you're in most of the libraries, when you receive a certificate, two things is typically done, right? One is you verify the signature of that certificate to make sure that it's a valid certificate, and then the other thing that you should do is look at the CN name or the SAN name and to see that the domain you're expecting matches the one that's in the certificate. When the developers are working on this stuff, they usually turn on that domain checking because they want to use their own local certs, but then oftentimes they forget to turn it back on and then they deploy code. So we see this often is that the code is not doing the right level of checking, and then what that'll end up doing is that you can accept a cert. Your app will accept a cert from anyone that intercepts that traffic and sends you a certificate. So that's something to be mindful of when you're implementing TLS in your application.
Absolutely.
A lot of people in the security field, they brag about their CVEs, right? Or not brag about them, but they're proud of some of the bugs they found. Mine is the opposite. I contributed code to Apache HTTP client, and the code I contributed, at the very line of code I contributed, ended up getting a CVE filed against related to the host name checking in the Apache HTTP client. Okay, moving on. What do you guys think? One more
note. When you're setting up servers internally or externally, there's a lot of tools you can use to check to see if you got it right. Again, if it's an externally facing server on the internet, you got SSL Labs. I showed you a link to my server just to see how test I'm running. But if it's a local machine, I like Dr. Wetter's test SSL script, which is really well maintained. He's on that every other day or so. So the idea is I'm not just going to deploy and hope things go right. I'm going to use a modern configuration generator. I'm going to tweak that config, and I'm going to use modern tooling to verify that I set my server up correctly. These are the different mature steps you want to take in development. Let's go.
What's your guys' take on wildcard certs? I love them myself.
I was going to talk about, oftentimes people really don't understand what the potential threat scenarios with this would be. The problem with using wildcard certs is, imagine you have 5 different applications. One of them was not written very well or has a vulnerability. If that one gets compromised, the private key that's accessed by that application is now exposed, and it'll compromise your other 4 applications. So for that is often not a great idea to do. And what we also don't like to see is that, I'll see this often, is the client uses the same one in production and in development. That's also not a good idea, because you're in dev, you have looser practices, and then the private key gets exposed, and then that'll also compromise your production applications, right? So you want to segment as much as possible, particularly in your based on risk, risk profile, and try to separate them that way. But
the wildcard cert, Julius, you got one private key managing a whole bunch of different domains. So one key compromise, it wipes out.
Yeah.
And also it's you have all these different subdomains that are rolling around. It is a little bit more vulnerable to subdomain takeover and phishing, which is end of times for your whole server. So wildcard certs are just less secure, period.
Yeah. I mean, it's like a master key. If someone gets their hands on it. then although I mean our Amazon load balancer on our stuff right now, we have set up a wildcard cert on the load balancer, and Amazon provisions it. Amazon's in charge of the private key. Amazon doesn't even let us get even close to that private key. Amazon auto renews it every 3 months, so I'm kind of happy with that.
But ultimately, I guess, yeah, because if you're deploying it to an API gateway or something like a gateway where your application code doesn't touch it, then that's fine. But if you have the case where you're deploying the application and then the private keys on that server, like in your Tomcat or whatever, that's not such a great idea.
Yeah.
So, yeah, our client certs are a good idea.
Thoughts on client certs?
Jim, you want to go first?
Anyone do you remember those? Those are like, that's like a VH.
Client certs implies two different architectures. It implies browser-based TLS certificates in a browser client, but it also kind of leans towards mutual TLS.
That's right, 100%.
Big part of like microservice kind of security. As
exactly.
We have this mesh of services, we want TLS intra-service that's enforced in both directions, right? So client cert is basically saying, I want to use certs in a stronger way for authentication. Client-side cert says, like normally when you set up a server, TLS server, and when you're doing it one way, anyone can anonymously connect to that server and establish a TLS connection with it. Any client that supports the right protocol. But when you're doing client-side certs or mutual TLS, the server is basically set in a mode where no one's allowed to connect unless that server assigns the client a cryptographic certificate unique to that server typically. So now I'm doing heavy network restriction at like layer 3 on the network stack, limiting who's allowed to connect to my server at the network level unless they have the right cert that I, as the server, assign to them. Now, I can do this at the client in a browser. It's kind of hard to scale that, but I've seen some intelligence services do that. And more typically, I'm implementing client-side certificates in a mutual TLS environment between microservices. For example, I got a database and I want to lock, it's in production, I want to lock it down. So I turn on mutual TLS and I have the database create some certs that I give to like my web server, my API servers, and that's it. Just the production servers that need access to that database. No one else can connect to that database. They don't have the right cert. So
do you see people really doing that though, or is that
oh my god? It's like
aspirational.
If you're not doing it in a microservice mesh, you're out of date at this point.
Yeah, 100%. Yeah, totally.
Oh, this is required implementation for a secure microservice mesh. In fact, services like Istio, they'll set this up at the config layer
automatically. Yeah. No, 100%. This is, you have to be doing that. And I see so many companies that, Jim, they're not aware of it. Like we go in there and then they have TLS right up to the edge. You're like, oh yeah. And then what happens that after the application gateway or the application load balancer, no TLS downstream, but they should be doing mutual TLS. But if they're trying to do it manually, it's a nightmare trying to like configure, client certs on the services. But what you want to do is exactly what Jim was saying, using a platform like Istio or something that will take care of that, create a mesh for you and create
it's called SG?
Istio.
Istio
in the chat.
The Istio service mesh. Istio is an open source service mesh that layers transparently onto existing distributed applications. Istio's powerful features.
Istio service mesh.
Provides
Istio, like
Susan
Donut.
ISTIO.
I'll post it in the chat there. I put it in the
ISTIO. Okay.
And like service to service communication with TLS encryption, identity-based authentication similar is built in at the config level. So you config it, go, and it will set up mutual TLS based on your configuration. It's really impressive. And this is one of many ways.
Exactly.
This is one of many ways, buddy. So it's like, this is not the only solution. It's one of many. That will automatically set up and mutual TLS for you in your service mesh, so you're not hand configuring it. So yes, Julius, yes.
Illumio, we use that. We use
Okay.
There's another product called Illumio. There's a whole
Illumio.
bunch of them. Yeah. But like those guys call it microsegmentation. These guys call it service mesh. But like at the end of the day, that's what they're doing. They're setting up secure connections. Illumio is doing it through IPsec. They basically set up like, instead of mutual TLS, they set up like IPsec tunnels between all the containers, and then they create these microsegments or whatever. But yeah, like certificate, the next one there, Julius, how to manage certificate expiry. I mean, if you're in the cloud or using one of those services, like, in AWS using their certificate manager, they'll rotate it, or in Azure, they'll try to do that. But it becomes a little bit of a challenge if you're not in one of those cloud environments.
CI/CD, baby. CI/CD, automate certificate renewal and stop the nonsense. That's
exactly.
It's all about
100%. And you know what's really sad though? So many people are not doing it. Like, we go into these environments, they're like, certificate rotation, what's that? Oh yeah, the last time we rotated it was never. It's that, and that's quite common. So we need to.
I'm not into it. Not into it
at all. No.
Or a year ago. One thing though, I was thinking, right? Like, so these days you can do like Let's Encrypt, and it'll like auto provision the certificate every 90 days or something.
Yeah,
right?
It's like I said, it's scripted. Let's Encrypt provides automated scripts that you tweak and run on your server that will automatically update your certs on a regular basis. You should do that kind of stuff everywhere. Like the idea of rotating once a year. No. Rotate every couple days, or rotate every hour.
But
why not?
I had one question about this.
Netflix does it every week.
Oh, really? Wow.
Yeah.
Just my question about this though is, so suppose I set up CertBot, the Let's Encrypt, and it's going to get me the fresh certificate every 3 months, 90 days. But when we were originally saying, we were saying how you should also configure your TLS, right, using the Mozilla TLS generator for stuff like that, or or generally the vanilla Let's Encrypt config is pretty decent when you first get it, but you should also, like, my question is, that config kind of gets stale, right? Like, suppose I go to the Mozilla TLS generator today and I get this beautiful TLS config and I put it on my server, and my server has the best TLS config ever, but a year from now, 2 years from now, that config is going to be stale. So I just question.
Well, Julius, damn it, we should be scanning our servers using continuous monitoring, damn it.
Okay.
I use a service called by Ivan Ristic. I use a service called Hardenize. Why I like Hardenize is because the person who wrote Hardenize is the same person who wrote SSL Labs, that level of rigor. So I use continuous monitoring against my TLS stack. Okay. The moment I have a cert out of date, or some configuration has changed, or even more importantly, like those who build Hardenize or SSL Labs or other scanning engines, they want to deprecate a certain kind of encryption or a certain cipher, I'll get an alert in real time that my setting is going below A+, right? My setting is A+, Julius. A+. I like to keep it there because people look up, like, I teach class and talk big smack, talk a lot of games, so I better have my house in order, right? I like my A+, and Hardenize and 100 other services will alert me as soon as I am misconfigured in some way. I think that's, again, CI, CD, automated scanning, DevOps, that's usually the right answer to these problems.
Totally.
Farshad, any comment there?
No, and I mean, I agree with all those sentiments, right? And what I was
I didn't hear that. What was that?
I agree with your.
Just kidding.
The thing is that, like, we went down this journey at HSBC back in 2014, 2015, and then we had brought a new CISO, and he was all about this automation. So Jim, everything you're saying, he came in and he said, like, wow, you rotate once a year. What is this? Like, Netflix is doing it every week. They were deploying all of their containers every week, refresh with fresh new certificates and everything. Yeah, and he's like, that's where we need to get to.
Love it.
And so we went on this whole mission of trying to put all the CI/CD stuff and do exactly that, right? But every week. In this day and age, why would you do it any other way? Like, if it's free to rotate and all these things can be automated, the challenge that a lot of these companies face is that automate, like getting a good DevOps guy that can come and help them put that stuff together. And that is what they face usually. So they end up not, and then also they have a lot of legacy or tech debt, and that's also difficult oftentimes to get away from. But cloud also. And then really
finally,
more slides.
Which was that last thing you mentioned?
Keep it rolling. More slides. Older clients.
More slides. Okay, just on this last
no older clients.
I suspect. I mean, if you. no older clients. I was trying to build Log4j 1.2 the other day during the Log4j fiasco in December. I just wanted to, see like, well, what's the situation with Log4j 1.2? So trying to build it from source. And you need older Java to build it. And then older Java can't build it because older Java is trying to go to Maven Central, and Maven Central won't talk to it because Maven Central is like, no, you need to be using TLS, you need to be using modern ciphers. So it's quite funny, right? Like I could not build Log4j 1.2 because of the TLS infrastructure is modernized, hardenized.
Right.
Okay, so yeah, if you're on older clients, sorry, you're insecure, and you better get off of them. Okay.
Gotta get off.
Yeah. When should we use TLS? Always. Are plain sockets okay sometimes, guys?
Not really. Nope.
I guess we do run plain sockets behind the load balancer. So
nope, that's a bad idea.
Probably the only time.
That's
bad idea.
Oh, really?
Oh, yeah.
Don't even run plain sockets behind the load balancer.
AWS themselves, Amazon says, like, there's a quote somewhere, I can get it later for you. It says, if you care about your data security enough that you use TLS until you reach us, you should probably continue to protect that all the way through to wherever you're going. They literally TLS all the way. If you don't care about it, you're not doing it to begin with, then don't do it. But if you're doing it, you just got to be all the way. Yeah.
Okay, even behind the load balance.
It's public cloud, right? Like, that is not a private, it's quote unquote private, but private in the sense that they put you in your software defined network, but it's a public cloud for all intents and purposes. So you should treat it that way. That's pretty much what they say.
Okay, never okay. Okay, done with TLS. Moving on to other things.
If you're doing app level encryption, it's okay. If you're
doing app level, you've got another layer. Yeah.
Like if I'm sending a JSON web token through it, that's fine. You can modify it, but it's a digital signature based high integrity token that needs to be verified, has a digital signature verified server side. So there's some weird cases where it's okay, but it's not okay. It's not.
But you know what? It's totally like, so if you do the application layer, it's, technically that's an end to end between there. We have some clients that do it both. They do the TLS and they've got the application layer inside. They recite all various reasons for that. But yeah.
I'm with you. Hey, by the way, I would bump 2 up to 3 on this slide, Julie. I would say just use SHA-3 at this point. It's widely available in most languages now. All the different primitives like macking, they have the SHA-3 variant of macking. It's relatively recent. I would say just use SHA-3 and use SHA-2 if SHA-3 is not available. And it's a small change. I would never use SHA-1 or MD5. And I'd try to use hashing for the right reasons. I'm almost never using hashing by itself. I'm using hashing as part of another algorithm, like another digital signature algorithm, using the SHA-3 variant of that digital signature, or some kind of MAC message authentication code utilizing SHA-3. So I'd bump it up because SHA-3 has really hit the different languages in the last year or so.
Okay, SHA-3.
But SHA-2 is good. There's no known like mathematical bypass in the world of SHA-2 like we see in SHA-1. So SHA-2 is okay, I guess. But I began notifying my customers to start the SHA-3 migration in classes starting last month.
Oh, okay, wild. Okay. Moving on. And then there's this variant here, this 512.256 truncation. So apparently that makes it even more better. Okay, moving on. Random IDs, just use 256 bits for random IDs when you need random IDs, and then always get them from devu random, which is available on Mac, which is available on Linux. A couple questions. Any thoughts on fancy GUID schemes that you sometimes see out there, or UUID schemes? I just think just get the 256 random bits. Like don't do weird structure.
So the one thing that usually comes up is, are GUID secure? And like, if you're just using regular one, it's not. I think you have to use, Jim, correct me if I'm wrong, version 4. There's something because the seed in the regular one, it may not be as secure. So if you want to rely on it for security, it has to be a version 4, I believe.
Okay. Oh, hey, Joseph.
My name is Cookie.
Okay.
Hi, Joseph.
Hi, Joseph.
I'm just gonna put him back in the room. I'll be right back, guys. Sorry.
Yeah, because it's funny. We often see that the developers are using GUIDs for secure references, or as a token that someone can use to fetch something sensitive. But yeah, if you're not using that version, then you will end up having collisions, I believe.
I'm with you. From a developer point of view, I give real specific advice about how to generate random numbers, right? I usually don't want to go to the OS to grab random bit stream, but like
exactly
in Windows, if I want to do random numbers for cryptographic purpose, then I'd use the bcrypt gen random function from the cryptographic API. And that's one of the better random number generators.
exactly.
In C#, I would use system.security.cryptography.random number generator. That's .NET or .NET Core. That's the better random number generator from .NET. In Python, I would go to os.urandom or use the secrets library. In Java, I would use the secure random class, the java.security secure random class. In JavaScript, I would use window.crypto.getRandomValues for some kind of array for client side, or I'd use crypto.randomBytes for something like Node. And I'd probably get a module like Node Sodium for server side stuff, the Node version of libsodium. But for all and Java, I can get secure random is really good. And same with Windows and C#. I have good ways. I don't want to use stuff like math.random or similar insecure low security random number generator functions if my goal is cryptographic, like to create a key or something. So that tends to be my advice for my courseware as a teacher, right? I grabbed the slide and read it for you, but those are my more low level recommendations at the language level for random number generation. And I like GUIDs, especially GUID like with the higher bit range and like the V2 GUID, I believe. GUIDs are a nice easy out for random number generation. So I like GUIDs too.
And I think, Jim, also if they're in the cloud, like in Azure or AWS, I believe the Azure Key Vault has a secure random number generator function that you can use. So if you have access to that or an HSM, they can also generate that for you.
Moving on.
Cool.
Storing passwords. Just try to tell people just don't ever store passwords.
Well, he's got to get stored somewhere.
Someone's got to store that password.
Someone's got to store that password.
If you're using passwords,
it better not be you.
Yeah.
I mean, let someone who's focused on that domain, right? Like someone is making a identity provider. They're going to work. That's all they do. They're going to make it hardened. They're going to make it really good. Make it their job, right? I mean, of course, if you don't want to pay for it, you're going to do it yourself. But
a lot of my customers, Julius and Farshad, are web scale, big companies, and a lot of them build their own authentication layers. And I don't recommend it, but
well, at HSBC, we did that, Jim. So it's funny because initially we had worked with IBM and we built our own, and then eventually at some point they realized that like there's other solutions they should leverage. So then they moved into things like OpenID, OpenAM, and other things they adopted.
It's not OpenID, it's OpenID Connect.
No, sorry, I was referring to OpenAM. The project, they used that OpenAM service and then they tied it in with LDAP.
I agree with this, but I agree. My little commentary aside, I agree with this slide. Don't do it. Use Auth0, Ping, Cognito, Okta, OneLogin, OpenID Connect. That's not OpenID.
OpenID Connect. Okay.
Because OpenID is deprecated.
Is the bridge into Google, Apple, LinkedIn, and similar login. So I do agree with this slide. I do. Let me say yes. I agree with this slide. Let's move on. What if you're going to store a password?
And I'll just say one thing. If you don't implement your own authentication, you're going to save a lot of ASVS section 2 and some of 3 pretty much go away. So it's nice. You have less stuff to worry about, right? There you go.
I don't agree with this slide. I'm going to debate it. My list is not Argon 2 is a bad idea. Argon 2 ID first, and I'd probably go with bcrypt next. I'd go with scrypt third. I usually wouldn't use scrypt anymore. I love you, Colin Percival, but I'd go to Argon 2 ID or bcrypt if I need a lighter weight algorithm. If I was working on a US government system, PBK, I'd use PBK DF2. And let me give you a whole cheat sheet on this topic. There's the OWASP password storage cheat sheet that talks about these 4 different algorithms and exactly what configuration that you should be using. What configuration should you be using for each of these algorithms? So that's my take on the topic. Not
So this
Argon
is a-
2, Argon 2.
And there's a cheat sheet for that.
Yeah, I just posted it.
There it is. Come on. And are you guys seeing this? The password storage cheat sheet.
Yeah.
Okay, Argon 2 ID.
And I'm giving
There we
real like
So that is,
recommendations on what memory to use, what iteration count and parallelism degree. So I'm being real meticulous in giving suggestions of how to not just use, but how to configure these algorithms for proper security.
And work factor 310,000, not 309,999.
Nope, don't do it. Don't mess
310,000.
with my numbers. Don't mess with my numbers, Julius. I sense your snark. I sense your snark, and I welcome it. I welcome it. Snark.
But everyone can see this the OWASP cheat sheet, password storage. Back to the okay. So this slide is wrong. Go to the OWASP cheat sheet on password storage. Okay, now moving on to encryption, symmetric versus asymmetric. And Farshad, you wanted to first talk about.
This confused me for a while. Like, I eventually got it, but it was like, when do you use one or the other, right? Because they both, you can use symmetric for encrypting, you can use asymmetric for encrypting, but should you, right? Now, and when and how and all that kind of stuff. But like, here's the one thing that I learned is that if it's the same device or entity doing encryption and decryption, then symmetric makes sense. So like one person, you got the one key, you fetch it, you encrypt your own data. If it's two parties, you got a symmetric key, you got to share that to the other party, right? So oftentimes if in architecture, if you have systems where there's, say, for example, one party has to sign something, the other party has to verify it, don't use symmetric cryptography, because then you have to, if you use HMAC, both parties have to have that same key. For that, you should be using asymmetric cryptography. One uses their private key to sign it, the other one uses the public key to verify it, right? That's a much easier way. You can share the public key, all that kind of stuff. So that was the lesson number one, is that if the parties are different parties involved in the process, i.e. encryption, decryption, two different parties, signing, verification, two different parties, that's a job for asymmetric. If it's the same party, that's symmetric. Now, having said that, should you use asymmetric for encryption? Not really, right? Like, it's not as efficient. It takes longer. And oftentimes most algorithms will only let you encrypt a payload that's the length of the key, right? Again, I learned this the hard way. I'm like, oh, yeah, like that's designed to encrypt a secret or something small, then that secret can be used to encrypt data. So oftentimes you'd use as key exchange to wrap a symmetric key, then you go on about your business using the symmetric key to encrypt the larger data, right? So that's mostly used as a top level key or wrapper key. Anyways, those are lessons that I learned. And it was like, it took a while for all that to click in. And I'm like, okay, I better make sure everybody else's benefits from those lessons learned, right? But
And that like asymmetric channel, that's gotten a lot more formal. Like those are now key exchange algorithms. That's
exactly.
It's like elliptical curve, Diffie-Hellman and stuff like that. It's like, it's not just asymmetric encryption like RSA. It's formal key exchange algorithms, which is slow, to exchange symmetric key material and then switch to symmetric, which is super fast, but you need a shared key. That's how TLS works.
Exactly.
And I configure it and I'm done. All this happens behind the scenes of my server.
Magic.
I get the sense these days as an application developer, if you're looking at ways to roll your own asymmetric or symmetric, I mean, if you're suddenly needing to do either of these, probably something's gone wrong somewhere in your requirements.
It depends on what you're trying to do. Like we had a few clients that are building, remember we were talking about application level encryption inside TLS. So they had a requirement for like, because in case the TLS links are intercepted somewhere, et cetera, they wanted end to end. So what they were doing is they were using RSA, like, they would encrypt and, they would have public-private key pairs on both ends and then, create their own tunnel within it to then exchange their own, doing all the things that Jim mentioned, but in addition to what TLS does for that extra layer of security across the entire path. So that's not every use case, but it'll be like, when you're in like financial sort of sector dealing with some of those types of applications, that's when we see this type of design.
Okay.
What's the next topic?
So if you do need to do some, can you guys see that?
Yeah.
Okay. So this is where both sides have the same key. In this case, just use the HSM, right? Like just use KMS if you've got it, because it's just going to handle all the headaches for you.
Right. I guess, and that's the other thing to be mindful of as well. Like, because let's say you're going to use the KMS in AWS, right? Like, well, what is the appropriate use? Like, let's say you want to encrypt something, your application wants to encrypt something. Well, what you're going to do is you can either to have sometimes an encrypt function, you can send the payload and it'll encrypt it in there and return the encrypted payload to you. But that may not be efficient for you to make that call every time to have everything get encrypted inside the KMS, right? In that case, what you do is you have the KMS give you an encryption key. So you wrap the encryption key that you're going to use to encrypt and decrypt all your data. You have it wrapped by the KMS, and then when you need to use it, you simply just unwrap it, keep it in memory, and then you can do all the things you need to do. Now, ASVS will tell you, and then Jim will tell you that you don't want to keep that key in memory for too long. So it really depends on the use case. Like if your service is constantly encrypting and decrypting, then that's a use case. You need to keep it in memory. It just doesn't make sense to keep unwrapping it. But if you're using it periodically, then you should find a way that you can clean it up. But that's also easier said than done, right? Most languages these days, like JavaScript, it's not going to let you clean things out of memory. Java is kind of iffy with its garbage collection, right? So yeah, if you're doing C++, that'll be a lot easier. But for a lot of these modern languages, cleaning it out of memory it can be challenging. So something to be mindful of.
And then I understand that
there's a newer mode for, I'm sorry if I'm off topic. There's a newer mode for GCM. That's GCM Civ mode. I'd recommend, and I'm dropping that in Wikipedia. I'm sorry, I'm dropping a Wikipedia link to this in our chat here. I like GCM, but GCM has problems with nonce management. It's important because it's for US systems, right? AES. Xsalsa Poly 1305, I don't think that's certified for FIPS and similar. So you have GCM mode, but again, nonce management's brutal. So AES GCM Civ mode, which is somewhat available in different systems, is going to make that nonce management, it's a lot more forgiving in that way. Also, we see that there's also AGIS 128L and AGIS 256. That's twice as fast as GCM with similar security characteristics. And take a look at the research from Bart Preneel. Bart Preneel is the professor that taught the two engineers who wrote AES. So Bart Preneel kind of guided the AES team early on. He really likes AGIS as a symmetric block cipher. And so those are just some of the more bleeding edge recommendations that are not Xsalsa or not just use a key vault. It's like in the American AES range. That's what I would look at.
And Farshad, you wanted to talk about HSMs for a little bit?
Yeah, that was another sort of a black box for me, for the lack of a better word, when I sort of went into this field. And I remember asking my colleagues, I'm like, hey, who knows about HSMs? A lot of them didn't. So I had to kind of dive in and read and learn all about them. But at the end of the day, what are they? They're a tamper-proof device. Like if you're using, and they have different shapes and forms. Like the ones that's often used in enterprises, there'll be network HSMs, right? So it's just like, it literally is a 1U rack mount server, but it's got all these detectors that if you open up the case, it'll raise alarms and has other protections. Some of them are fireproof and beyond being tamper-proof, it really depends on the FIPS requirement, the Federal Information Processing Standard, and all that kind of stuff that in the industry that you're in. But at the end of the day, the idea is that this is a tamper-proof box that no one can get in, and you've got like all your keys and secrets in there, and then you send data or other keys and secrets in there to be wrapped and given back to you. So the actual the actual key that's used to perform those operations is never exposed outside that tamper-proof box, right? Which makes it attractive. So like if someone breaks into your application, then hopefully they can't go in and they can't get the actual key material, but they can, if they break your application, they could use the operations that HSM provides, right? So this is where it gets a bit interesting, architecting these solutions and making sure that, across your applications, you're not using the same key material to access that HSM domain that you've created or the security world and all that kind of stuff. But it's not often that it's usually required in the financial sector. Outside of that is not, but it's a good idea. Like these days, if you're in the cloud, like we run an application in Azure cloud and their premium key vault, which doesn't cost a lot. It's backed by hardware HSM. That's, you get your own dedicated environment. So highly recommend using it if it's a possibility.
Like Farshad was saying earlier, like I want to use a KMS and an HSM, especially in the cloud, but I don't want to spend a lot of money. And so if I just put all my keys in a KMS and I use that for encryption decryption, I'm going to pay out the nose for all those operations really, really bad. So I typically use a KMS for like the master key that's then going to encrypt a key for each service. And each service key is going to encrypt individual data encryption keys. It's like a key family, and like libraries like Google Tink handle this really well. There's a very famous article from Cash App. And if you scroll down in this article, you'll see how they have an AWS KMS key. When the server boots up, it's going to take a service key out of the KMS and decrypt it. And that's going to allow the app to decrypt their data keys and rotate their data keys to encrypt actual data. I love what Cash App did here because it still uses a KMS and it lets me rotate different keys in the infrastructure for different apps individually. So I can really, and the actual master key, that thing never leaves the vault. I can get away with rotating the master key on a very irregular basis, like yearly. And then the individual keys for each service, I can rotate those every day because they're separate. And then I can then use like for the actual data encryption, I can like, as I'm decrypting data, re-encrypt it with a new key on the fly because I have that data and key in memory for a moment. I love what they do here because it gives me like, and usually that master key should be one master key per app. I wouldn't share the master key. If you really want to be cheap, you can, but probably want to have a separate Amazon key for every app. And holy cow, that my ability to rotate keys across this infrastructure is super powerful. And again, I just put the link up in chat that points this out. But yeah, I wouldn't have.
Thanks for that. Sounds like a good pattern for application
I would almost
developers.
never put all my. I'm sorry. Sorry, Julius. Got a delay there. I would almost.
No, go ahead. Go ahead. I'll stay quiet.
I would almost never put all of my keys directly in the vault for operation because then like every login, every token verification, I'm going through a vault. So I want to do it as best I can in an efficient way for cost and for performance. These HSMs and key management systems are real expense and performance bottleneck. So if I can use them to unlock other keys in my app, I save on the cost and on performance problems that show up with heavy KMS use. There you go. That's my take on it.
Sounds good.
Here's a short slide.
HMAX. Yeah. So this is kind of what I was alluding to earlier, like when you use HMAC, when should you sign, right? And that really depends. If both of them, I mean, they can accomplish the same objective. They can tell you whether your data was modified and prove its authenticity. But like if you're using HMAX, then that's the same key that does the verification and the generation of that HMAX. So therefore, it's a bit more of a challenge to share that key across multiple parties. In that case, if you have multiple entities involved, then you should be using asymmetric cryptography. So what you should do is sign the party that's generating that data would sign it using their private key, and then the other parties that are receiving it, they use the public key to verify that signature or the certificate of that entity. So again, it goes back to, is it the same entity doing both operations, or are there different entities at the end of each operation? And then that would be a case for deciding HMAC versus a signature. So that's my piece on that.
We have Lance Kelson raised their hand. I'll just hit the allow to talk button on them.
Go for it.
So Lance Kelson, you're muted, but you can unmute if you'd like to say something.
Hey, Lance.
I'm sorry, hit the wrong button.
Oh, no worries.
No worries. Yeah, Jim, anything to add here?
Like when I'm doing microservices, I like to use a proxy pattern where I'm not like directly interacting with all my microservices from the client. I'm interacting with one proxy on one host that will proxy all my requests to different microservices. So my connection with the browser or a mobile app and usually the gateway is a reference token, which is an HMAC-based token, because I'm opening up a session basically with the gateway, and the gateway gives me the token, and the gateway consumes the token to see if my session is open. So in that case, the same server deploys and accepts the token, and HMAC is great. Then behind the scenes, I'm gonna verify the token across all these different microservices. In that case, I want to use like RSA or Edwards ECDSA or some other digital signature asymmetric algorithm, because I don't want to have to distribute that powerful key to all the different services. So in these proxy pattern microservices, it's called the backend for front end pattern, the BFF pattern. I get like an HMAC token between the browser and the gateway, basically a session. And then I use a RSA signature and a JSON web token as I deploy tokens throughout the mesh to get access to APIs. So it's all about if it's the same server is deploying and verifying the token, and that's it, HMAC is great. But in most cases in modern microservices, it's not. You're going to want to use something other than an HMAC. And it's the default in JSON. It's the default in JSON web tokens these days. I don't like it overall.
Okay, well, speaking of asymmetric then, any guidance here for people trying to run asymmetric crypto?
Guide to make sure you're using the algorithms that are approved and not deprecated. You can always refer to, you know, there's various standards. Like a lot of times people will, depending on what your goal is, right? Like I'd say align it with FIPS, but that may be too much for some, but you can align it with a number. The NIST has a number of, I can't remember the number of the NIST standard that recommends the current algorithms that are strong. Let me just Google that actually. NIST. But yeah, that would be the one thing that I see often people getting wrong, is that they don't use the right version of the algorithm, et cetera, et cetera. Graphic algorithms. Cryptographicness, this one, I think. Yeah, we can keep avoid RSA and Diffie-Hellman. Why do we want to say avoid those two?
That was just based on my own research. I just see Thomas Pachek. I don't know how to pronounce his last name. I'm just saying to avoid them. So kind of, you know, I trust Thomas.
I don't know. Yeah, that's contextual. I wouldn't say you need to avoid them. I mean, Diffie-Hellman has its time and place, and depending on how you're using it, and RSA also as well. I mean, if it's the argument that like soon RSA will not withstand the quantum attacks, yeah, that's coming, but it's not here yet. And still, you know, FIPS and everyone, they still fully recommend RSA, and you can't crack them yet. But yes, there will be a time where quantum computing comes along and it'll be able to do it. But and you know, so I would disagree with that statement, but I think there's more context there that we're probably missing.
Jim?
I think he was on mute.
Oh yeah, Jim, you're mute. Ask to unmute.
I really like libsodium. I really like Google Tink. These are some of the best
Google
practice.
Tink.
Yeah, Google Tink and libsodium. Just use libsodium is actually a really reasonable thing to say. It's one of the best world-class cryptographic libraries out there. And I hate to say that, but yeah, just use libsodium is not a bad idea at all. Cheers.
And then asymmetric signing, again, use libsodium. I mean, DSA has been, people have been saying avoid DSA for probably over a decade now. Okay. Signature verification.
Yeah, so I think we talked, do you verify certificates? Well, you have to if you're going to use them, right? You better make sure that the signature is authentic. And then of course, like I said earlier, if you're an application developer and you're trying to receive that cert and then act on the payload, you better also make sure that it's coming, the domain is the one that you're expecting it to be, right? So you check the CN or SAN in that cert, and then you're like,
yeah, although,
right?
Oh yeah. Although these days, like pretty much any HTTPS library that you're using is going to do that check, right? So,
but then people disable it.
TLS client, you know.
But then
yeah, so be careful if you're disabling it.
Yeah, exactly. Yeah.
Although I would, yeah, try and get the developers not to disable it and just actually run full TLS even in their dev environment. Because you can just put entries in etc host.
I agree with that. I prefer my dev environment to be all set up with TLS as well. That's just a good idea in general to dev with authentication, access control, encryption controls, all enabled. This is something that the Automotive Linux group recommended in their secure development recommendations a long time ago. I concur with that. Keep your security on in the dev environment. Build with security controls enabled. Cheers.
With the JWT, like, should you be verifying the signatures on those, or do the JWT libraries tend to just do that for you?
JSON Web Token. Well, you want to configure, are you using an HMAC? Which digital signature are you going to use? Do you do proper server-side enforcement? Are you keeping your JSON Web Token libraries up to date? Are you using a good JSON Web Token library with a good security, good security history? Back in 2015, 16, you can just set a JSON Web Token signature to none, and many libraries would just skip the signature. So I want to make sure like it's not just the JSON Web Token, it's not just the JSON Web Token asserting what digital signature it contains. It's about your server endpoints enforcing a limited list of signature types that must match the token. So that's something that's really important in the world of JOTs, is like, how do you verify what's an allowable signature? And that's, again, specified in the token, but needs to be enforced server side. You can't let the token arbitrarily pick a signature type.
Yep.
Okay, coming to the end of our talk here. So the advice Thomas was giving at the library is popular, and be careful with GCM. It seems to be, that's pretty good advice. So no bouncy castle, no OpenSSL. Don't use these low-level libraries. If you find yourself digging into the weeds of your platform, I'm sure .NET and Java also have like low-level crypto capabilities built in. Like, once you're in there, you've gone the wrong way. How to stay educated. This is what I put forward, right? Cryptographic right answers is a good little Google search, because there's been a series of articles with that title since 2009, since Colin's first crack at that. And then, as always, keep an eye on OWASP, because they're putting out good stuff on this as well. Okay. Conclusion. Yeah, it's very easy to shoot yourself in the foot with this stuff. So don't roll your own. Use as much cloud infrastructure as you can. Honestly, I love having all my TLS dealt with by Amazon and AWS. Thank you, Amazon. Thank you, Jeff Bezos, because I don't have to worry about TLS anymore. Any final words, Farshad, Jim?
Final words is, make sure that when you're doing any cryptography, that that you know the parameters, that, because I've seen what happened is that they implement encryption or signing or whatever, but they're not instantiating the function with the right parameters. And then, you end up not encrypting at all. Like, in fact, I saw one time developer said, yeah, I'm signing my JOT tokens. I said, well, what algorithm are you using for that? He's like, well, I'm not sure. So we went to look at the source code, and he was not specifying any. And when you don't specify any, you're not getting anything signed at all. So, those are the things that I see a lot, is the parameters not specified properly, not understood. So they're doing the function, but is it actually doing what it's supposed to do? So that's my takeaway for the audience.
Well said, Farshad. Me, it's like, use cloud infrastructure for key management. Read that Cash App article and other very bleeding edge articles on implementing good key management in a cloud infrastructure, and use Google Tink or libsodium to do your low level crypto. And a lot of the problems that show up go away with just those components. That's 100%. The direction I would move. That's the direction I'd move in. Thank you, Julius. Thank you, Farshad.
Thank you, everybody. That was a fantastic conversation. Thank you.